we don't think that either. On the other hand, she talks about how we see things, how we see the sky, how we see the sea. And you notice she did not use the word mind. She used the word brain. Now, ordinarily, if you were thinking about imagine the sea, you would say what? Well, in my mind, I have a picture of the sea. In my mind, I have a picture of the sky. She didn't say that. She said, your brain. So might she have been saying the mind must be in the brain? Yeah, she might actually have been trying to say that. She might also have been trying to say that the sky and the sea seem pretty infinite, pretty deep, pretty wide, but the brain, she says, is wider and deeper. So maybe what she meant was, metaphorically, poetically, that there was more to you even than there was to the sky and the sea. So she might have meant that too. And then, in today's language of thinking about learning, she might have meant the brain makes meaning up. That is, makes something make a difference to you about the sky and the sea. So any of us might stand out and look at New York Harbor, watch the ocean, watch the harbor, watch the waves, watch the sky, and each of us might come away with something different. We'd all see the same harbor. We might come away with different impressions. So she might say, yeah, that's right. You're using your brain, remember, not your mind, your brain, to make meaning. That is, to take something away from the sky and the sea that you're looking at. So she says, yeah, the brain makes meaning, means it contains with ease the sky and you too. So it understands yourself in relation to the sky. So yeah, she might have been saying the brain makes meaning. So what she was trying to say in some ways was, it's all in your brain, as opposed to it's all in your mind. It's all in your brain. And what she meant by it's all in your brain is an interesting thing. What she was trying to tell us 140 years before current neuroscientific studies was that there is a very important relationship between this thing we call the brain and this environment we call the world. And what we learned about that 140 years later is just what she said, that the mind turns out to be in the brain. It's the brain that links us to the world. Whenever we are linked to the world, we are learning, which means making meaning, taking away something personal from everything we do. So learning means changing your mind, which actually means changing your brain. So that's what she meant when she said the brain is wider than the sky and deeper than the sea. Now here we have to take a leap from the drawing room at Amherst in 1862 to research centers in 17 or 18 countries in 2003, 4, 5, 6, 7, doing research using neuroscientific imaging tools to see what that brain does, to see how we learn, how we understand, how we perceive, how we think, how we make decisions, how we make meaning. So I'm going to introduce you to a little bit of that work now that we've jumped 140 years from Emily Dickinson's poetry. Here you are looking at a landmark study done using a technique called positron emission tomography. Don't worry about the details. What this shows you is 4 pictures of brains. I'm actually going to take that one off. 4 pictures of brains when various things happen to the person who owns that brain. The color that you see in the brain, those images, the brighter the color, the more work the brain's doing. That is, the more brain is trying to do something in response to some stimulus. So if you hear me say the word brain, then your brain does what you see on the upper left. If you see the word or hearing or seeing on the slide, your brain does what you see on the upper right. If I say to you, okay, now think of a word for a large gray mammal with tusks, and you think elephant, then your brain just did something that looks kind of like the lower right. And if I say, now say that word, and you say elephant, it would look like the lower left. So the first thing we learn is that many of the things that we thought were parts of this thing called mind are actually physical processes that happen in this thing called brain. And the more we study it, the clearer it is that that's what happens. So here is a more recent, more detailed technique. This is called functional magnetic resonance imaging. And as you look at this, you see these two areas here, bright red in the back and then blue over here. What you're looking at is what it looks like when you hear music. Here's what it looks like when you see pictures. So your brain responds by doing work. So when we think of thinking, perceiving, sensing, hearing, seeing, speaking, generating, understanding, what we're talking about is that this structure up here at the top of our spinal cords actually is working. And it's doing something, and we can now see where it does that, how much of that it does, and what it looks like when it does it. It turns out we can even distinguish how much it likes and how much it pays attention to things that it's trying to do. So here are some comparative images using, again, functional magnetic resonance imaging scans. This was a British study about 3 years ago. You'll notice that there are several different pictures here. What they've done is to show these subjects, these research subjects, a variety of learning tasks and then scan their brains while they were doing the tasks. Notice that they have one group that they call semantic in green. Semantic means what your brain does when you simply ask it to memorize something. So you say, tell me what's 3 plus 3 plus 3 plus 3. You go 3 plus 3 is 6, plus 3 is 9, plus 3 is 12, plus 3 is 15, plus 3 is 18, 21, 24, 27, 30, etc. Or the state capital of South Dakota is Pierre. Or the capital of Washington is Olympia. When you've memorized those things, as you can see, you've only challenged the brain a little bit. Just this little green stuff happens. But now if you say, what does 3 mean to you? And you think, well, I have 3 sisters. I have 3 grandchildren. I have lived in 3 houses in my life. I ran away from home 3 times. I've had 3 jobs. I'm a faculty member. I've applied for promotion and tenure 3 times. I think they don't want me. I've written 3 books, read 3 books, fell asleep in 3 books. Well, that process of what does the number 3 mean turns out to require a lot more effort. And all this stuff circled in orange is analogical or conceptual thinking. So if we ask our brains simply to memorize, they don't do much. If we ask our brains to think, to come up with ideas, to be abstract, to have concepts, then they do a lot more. And we've begun to learn a great deal then about not just what the brain does and where it does it and how much effort's involved, but how it differentiates effort required in different situations. I'm going to show you now perhaps the most remarkable of these studies. This is a study using a technique called magnetoencephalography. And here is a magnetoencephalographic picture, which is about to turn into a movie. And I'll show you the movie twice. This movie represents what happens when you hear a single word. Everything you're about to see happens in micromilliseconds. It's going to take about 10 seconds in a movie. So imagine that it's being slowed down by a factor of 2 or 3 million. Remember, this happens every word. Every syllable, everything you see, everything you hear, everything you think about, some variation of this has to occur. So here you're going to look at what happens when you hear a word. What I'd like you to notice is that there will be an initial flash of activity in the brain, in the part of the brain which is responsible simply for hearing the word. So I say buffalo, and there's this little thump, buffalo. And then there's this immediate, what is that word? So there's this search for, have I heard that word before? What does that word mean? That will happen up in the front part of the brain. And then there'll be something down in the low part of the brain, which is that a scary word? Should I be running? Am I afraid of this word? And then there'll be something in the back of the brain, which is like, I think I've heard this word before. It's probably okay. And then finally, there'll be, was it buffalo? So repeat the word to itself. All of that will happen in micromilliseconds, and that will happen with every word you hear. So, if you will watch the screen for a moment, buffalo. Word is heard. Word is compared at the front. What's that word? Back in the